No matter how traditional their training, it can be difficult for papyrology's newest practitioners, a generation to which I belong, to conceptualize the conduct of research in the analog environments of yesteryear. Although the need for a well-equipped papyrological library has neither changed nor is likely to change, today's scholars also depend, inter alia, upon papyri.info for robust queries of textual data, upon pappal.info for diachronic illustration of the paleography of papyri, and upon Trismegistus, which permits one to drill down into all manner of metadata regarding ancient texts of all types. But the digitization of papyrology is not limited to advanced research facilitating instruments of this sort. Numerous institutional collections now provide open access to online images of their holdings, as a matter of course, a sea change from only a few decades ago when high-quality photographs had to be transmitted by post if they were available at all. And a principal benefit of born digital open access publications, such as the recently launched journal Pylon, is the reduction of barriers to both research and the advancement of knowledge. The benefits of digital culture for research and the many new avenues that computer-assisted quantitative analysis have facilitated are already clear from the presentations that have preceded mine. It is safe to say, furthermore, that the work of papyrology is not going to become any less digital in the future. But computationally informed methodologies are not born from the head of Zeus like Athena, fully formed and equipped for battle. And my focus today is on some underlying challenges in the sphere of text encoding based on my experience as an editor of Papyri.info's digital corpus of literary papyri. Put simply, much depends on the data. And unlike documentary texts, whose encoding in the Duke Databank of Documentary Papyri has established best editorial practices over the course of decades of work, the novelty of literary texts in the digital sphere has required new standards and technology to support the array of scribal diacriticals, punctuation, as well as symbols or marginalia, critical or otherwise. In the presentation that follows, I hope to illuminate for users how the development and editorial oversight of computational tools for these paratextual and material aspects of literary papyri is proceeding, why limitations unfortunately remain, and how we might overcome them. Papyrology has long been in the vanguard of digital humanities. Decades before the creation of the World Wide Web, teams in Liège, Milano, and Oxford began encoding the texts of antiquity's papyrological legacy in machine-readable format, a project taken over in 1982 by the Duke Databank of Documentary Papyri. Other catalogs and registries followed in the wake of the Duke Databank, including the HGV, the Heidelberger Gesamt für Zeugnis, the Advanced Papyrological Information System, Bibliographie Papyrologique, and the aforementioned Trismegistus. After it became clear that these resources would ideally be accessed via a single, aggregated online interface, from 2007 to 2012, the Andrew Mellon Foundation funded the Integrating Digital Papyrology project in several phases. Not only did Integrating Digital Papyrology unite hitherto discrete resources under a common data standard, the Epidoc Customization of Text Encoding Initiative XML, or TEI Epidoc XML for short, but it also developed the interfaces for navigating and editing papyrological data, the indispensable Papyri.info portal. In the larger context of digital papyrology, the digital corpus of literary papyri is the new kid on the block, aiming to provide textual transcriptions of ancient books and other non-documentary materials that were historically excluded from the Duke Databank. In December 2014, Trismegistus and the Leuven database of ancient books generously shared placeholder metadata for some 14,613 files to establish the corpus, which was formally launched at the end of 2017 after several years of development. Progress since then has been rapid. As of mid-November of this year, nearly 15% of the files currently in the corpus have been populated with textual transcriptions, which is remarkable for less than a decade's activity. Here's an example of one such text from the 8th volume of Columbia Papyri, number 204, also known as Trismegistus 61356. At left, there's aggregated metadata from Trismegistus, Apis, and DCLP, as well as the top portion of an image and textual transcription. And on the right side of the screen, a zoomed-in version of the textual transcription, complete with apparatus entries. It would be very nice if every text in DCLP had been entered comprehensively in this way, but the work will necessarily be proceeding for some time. The encoding of Papyri's paratextual aspects is somewhat more complicated than ordinary text, but the decades-long work of the Duke Databank provides some foundation. Because the Duke Databank and DCLP are accessed via a single portal, papyri.info, their technology overlaps considerably. I can show you what I mean via a demonstration on one particular paratextual aspect of a papyrus. Here's what happens and what needs to happen, for example, to get a scribal row cross into a digital edition in DCLP. Let's begin with papyrus. I've chosen BKT9 number 206 as my example. Now notice from Ioannidou's edition that the text begins with a cross. Now, to enable any future quantitative analysis of crosses in the papyri, it's important that we encode it somehow. Comparison with a digital image of this papyrus reveals that it is no simple cross, but rather a cross of the so-called tau row variety. The print edition, unfortunately, does not distinguish between the two, but in papyri.info, we definitely want to do so. In the language that the editors of papyri.info use, the simple cross is called stauros, and the tau row is called row cross. If we open the file in papyri.info's papyrological editor, it becomes possible to manipulate the digital transcription via a user-friendly interface dubbed Leiden+. As you can see from the screenshot, a row cross is encoded in Leiden+ by typing the hyphenated word row cross between a pair of asterisks. But the Leiden+ interface is only that. It's an interface, or a mask. It was designed to appear as familiar as possible to papyrologists so that scholars could contribute meaningfully to the entry and curation of papyrological data with minimal training and without requiring a deep knowledge of computers or code. Most of the time, a workshop or two is sufficient to learn the basics. But for my purposes today, I need you to pay attention not simply to Leiden+, but also to the man behind the curtain. Underlying every edition in papyri.info are XML files that adhere to the schema defined by the Epidoc customization of Text Encoding Initiative XML. When a user saves a transcription in Leiden+, papyri.info converts the Leiden+ into TEI Epidoc XML by means of a bidirectional grammar called xsugar. Here's the relevant section of xsugar that controls glyphs like row crosses. And here is the XML product that xsugar spits out, and which is eventually stored in papyri.info. As you can probably see even from a glimpse, XML is a highly structured language. That structure is what allows computers to process it easily, but it is unfortunately much less human-friendly as a consequence. In XML, the words row cross, which were placed within asterisks in Leiden+, take a different form. The equal sign and the quotation marks help us see that the attribute type is here defined as a row cross, while the rest of the line, which includes the letter G within a set of angled brackets, defines the TEI element that is required. G comes from a Japanese word, gaiji, that denotes non-standard characters or glyphs. The type of non-standard character that appears in this papyrus first line, in other words, is a row cross. A great deal of XML becomes clear once one understands the basic interplay of elements like G and their various possible attributes. Because row cross has been encoded in the XML, we can search for it in papyri.info. And here's what happens when I enter the word row into a text search. I get over 2,000 results. These texts all contain at least one row cross. And so when I click on our Berlin papyrus in the list of results, there in the first line, a nice row cross is clearly visible in papyri.info's HTML output. It's easy to take for granted that it displays neatly in this way, as if by magic. But once again, it's necessary to look under the hood at the transformative technology that makes that happen. Remember, in the XML, we had encoded G type equals row cross. Although the data in papyri.info is encoded and stored in TEI epidoc XML, papyri.info's output is the HTML commonly used by websites. Driving the transformation of XML data into a usable HTML output is an array of style sheets curated by the Epidoc Consortium. And for the sake of demonstrating how the sausage is made, I'll show you not only the XML for this papyrus's digital edition, but also the XSL transformation rule that turns G type equals row cross into the Unicode character for a row cross, as well as the HTML output itself. When the style sheet that makes HTML encounters G-type row cross in the XML, it replaces it with the Unicode character for a row cross in the HTML display. The purpose of taking you on this tour of papyri.info's digital infrastructure is not simply to show off the magic of the system. I also want you to understand that encoding aspects of a papyrus requires a number of complementary bits of digital infrastructure to enable the storage of data in machine-readable format, its retrieval, and the display of results in a way that conforms to a papyrologist's expectations. First, we have to determine the appropriate TEI epidoc markup for a given feature, following the published guidelines and schema. These are the rules of the encoding game. We can't just make them up, and we certainly can't break them. For a papyrologist to encode or interact with XML in the more user-friendly Leiden Plus interface requires comprehensive X-sugar support as well, so that Leiden Plus and XML can be transformed bidirectionally into one another. Once the file has been validated and saved, moreover, it also requires the support of Epidoc style sheets, so that it can be transformed once again for online display in papyri.info. If a textual feature lacks X-sugar support, it cannot be edited and saved in Leiden Plus, but only in the raw XML. And if a feature lacks style sheet support, it will either not display at all in papyri.info, or it will display in an imperfect form. Now, the case of a row cross is relatively straightforward because this character appears in documentary papyri, and it is therefore not new, technologically speaking. The digital infrastructure is already in place, and DCLP makes use of it. But let's take the example of something new and peculiar to literary papyri, such as this Cologne papyrus of Alcaeus, in which a scribe has added all sorts of lexical aids, including accents and indications of metrical quantity. You'll probably agree with me that these should also be searchable in papyri.info. But a transcription of this text has yet to be added to DCLP because, although a few of its features are already supported, others are not. Let's begin with those that are. Here's the first line in Leiden Plus, in XML, and as it would appear in papyri.info. So far, there's nothing unusual. Now, let's add the two grave accents that the scribe has added to the final word of the line. These are also fully supported. There is defined Leiden Plus that X-sugar converts to XML, and the Epidoc style sheets know that they should display them online via papyri.info's basic apparatus. Again, so far, so good. The problem arises when I attempt to encode the 4 metrical annotations that the scribe has added in the first line, which are only partially visible at the top of the image here. There is no defined Leiden Plus for a scribal mark indicating a breve or a longum. So I'll have to begin by adding it to the XML manually using the element high with the attribute rend defined as breve. This is perfectly good XML, trust me, I checked, and I can save the XML in papyri.info without breaking anything. But if I want to modify this papyrus's Leiden Plus, I will get an error because there is no defined X-sugar for transforming the new XML I've added manually. In the absence of X-sugar support and defined Leiden Plus, only a user who is comfortable editing raw XML can manipulate this text. The file is otherwise effectively locked for everyone else. Now, one of Papyri.info's goals is to enable the curation of data by the papyrological community, and any technological shortcoming that effectively locks a file runs contrary to that purpose. And even if I save it manually in the XML, it won't display in Papyri.info anyway, since the Epidoc style sheets do not yet define how to transform high rend Braille for HTML display. A user who accessed this text would not know that there are indications of metrical quantity without consulting the print edition or the raw XML, nor would she be able to search for them in Papyri.info more broadly. I might summarize a few of the challenges posed by literary papyri. The first and most important is that we need to identify in the Epidoc schema and guidelines the appropriate markup for what we wish to encode. As I've already said, Epidoc defines the rules of the game, and we can neither ignore them nor make up our own. The next requirements are for Xsugar support of whatever new feature is desired, so that there is defined Leiden Plus that can be converted back and forth between XML and Leiden Plus. And lastly, we must also ensure that the style sheets that produce Papyri.info support the new markup, so that the new features are displayed in a way that the papyrological user can understand, either by means of a particular Unicode character, an apparatus entry, or some other method. And then, of course, it's also necessary to teach the Papyri.info user base about these new developments. This last point about outreach is a crucial one, because while I've summarized some of the challenges that adding new features to DCLP's digital infrastructure presents, it's also the case that, in the absence of clear instruction and guidelines, the potential for entropy and a certain amount of chaos persists. By way of illustration, I wish to return to my earlier discussion of the row cross in BKT 9206. You'll recall that, in Leiden Plus, placing a word within asterisks is the mechanism for encoding a special character or glyph. Placing a word within asterisks when encoding Leiden Plus will produce a specific type of G in the XML after Xsugar has converted it. No new Xsugar is needed, in other words, for users to create any number of glyphs. Even Epidoc style sheets cooperate to some extent. If a specific glyph hasn't been defined, Papyri.info prints the name of the type within double parentheses, as in this example of magical symbols from the Supplementum Magicum. Following the launch of DCLP in 2017, the situation with glyphs quickly became chaotic. The novelty of literary papyri and the various kinds of symbols employed by scribes, the absence of a long-standing encoding tradition for literary texts, the lack of clearly defined standards, and the eagerness of many scholars to take responsibility for the texts that mattered most to them, meant that glyphs proliferated. Sometimes, this was a relatively benign phenomenon, where typos crept into the system or the wrong name for a given glyph was used. But sometimes scholars were using the element G to encode phenomenon that Epidoc guidelines has other markup for, such as the indentation of lines, aesthesis, milestones like the paragraphos, or figures like seals or drawings. None of these should be encoded in Papyri.info using G. And encoding them in this way is actually counterproductive, since they will not be retrieved alongside the ones that are encoded properly in a search. When I realized the state of affairs shortly after becoming an editor, I began to catalog and sort through the various types of G in order to enforce some sort of order on the data by correcting misuse, deleting errata, identifying glyphs used in literary papyri and defining the appropriate markup, and where possible or necessary, adding support in the Epidoc style sheets so that the darn things would display the way a papyrologist would like them to. Our spreadsheet currently includes 134 items, and to give you a sense of the chaos, 50 of those have since been deleted entirely, with 2 more pending deletion, while 11 new additions have been made. We expect that the number of unique G types to continue to come down as our work continues, and we're also preparing a revised help file in concert with the changes in order to guide users who would like a reference tool. DCLP is a new resource, and there still remains so much to do in terms of encoding texts. We may lack the 40 plus years of history that underlie the Duke databank, but we also have a unique opportunity to build into the system mechanisms and digital infrastructure that will permit future quantitative approaches to the paratextual and material elements of literary papyri. The importance of this point cannot be understated. If a future scholar wants to study, for example, asteriskoi in the papyri, DCLP will enable that work, but only so long as the asteriskoi are encoded consistently and are retrievable via computational means. The quality and machine readability of the underlying data, in other words, is of great importance, as is the functionality of the various bits of digital infrastructure that enable the curation, storage, retrieval, and display of the pertinent data. Thanks.